So the very first thing in risk management is to do this risk analysis, and risk analysis is typically done in the following steps. The very first step is to enumerate an organization's assets. Before you can do any risk analysis, you have to understand what you have first, both physical and intangible assets. And then we talked about this asset valuation concept, where we appraise the value of an organization's assets one by one, and then the next step is to identify risks associated with these assets, and we will then quantify the impact of threats against the assets we have. So what kind of loss we're talking about as a consequence of this threat getting materialized. So you need to consider that, and then you need to think about a countermeasure to somehow reduce the risk, in this case by either reducing the probability by introducing a new control. So that's costing money, so that's why you have to budget for security. And you also need to help in integrating both needs and objectives of the security policies into the business goals and intentions of the organization. So what this means is, whatever the security policies say have to go hand in hand with what business is trying to do to meet its business goals and intentions. Risk analysis is this process of associating threats with risks. There are largely two risk analysis methodologies available. One is quantitative risk analysis, and this one is really based on the dollar value of the loss once, for example, a threat gets materialized. How much loss would it incur? And the loss is represented in terms of a dollar amount. Another method is called qualitative risk analysis. In this case, we put less emphasis on numbers, and this approach is a little more subjective because we're not really talking about precise numbers, and we're also considering things that are intangible more in this type of risk analysis approach. So we'll look at both of these approaches in the following slides. As we discussed earlier, there are mainly two ways of quantifying a risk. One was in terms of probability, how probable a threat is. That's one way of quantifying a risk. And that probability is mainly based on the frequency. How often, for example, an incident occurs as a result of a threat getting materialized or a successful attack. Another way to look at this is also what kind of consequences a risk result in eventually. So mainly in terms of dollar amounts or cost. So how much does it actually cost for us to recover from that particular risk once it gets materialized? How we can recover from a successful attack. So we have some cost functions we can use to produce the dollar amount. So here are ways of calculating some of these costs. So one element of, or one example of this function is something called exposure factor, or EF, also called loss potential. So this means basically the percentage of loss for a specific asset if a compromise occurs. So what this means is, when a successful attack occurs, you have an asset, and how much of that asset is going to be damaged. So for example, if you have an asset that's worth $10, and if a successful attack occurs, how much of it is actually lost? Is it $2? Then the exposure factor in this case will be 20%, because exposure factor is represented in terms of a percentage. And then another function is called single loss expectancy, or SLE, and this is calculated by asset value in dollar amount multiplied by exposure factor. So for example, the asset value is $10 and exposure factor is 20%. The single loss expectancy is basically $2. So you're losing $2 once this particular attack, a successful attack, occurs. That's what we mean by single loss expectancy. But throughout a year, you could have many instances of these successful attacks. So we need to understand how many times this same attack, a successful attack, can occur per year. So that's called annualized rate of occurrence, or ARO. How many times per year this same attack, a successful one, can occur. So within a single year, remember that, and therefore we can compute something called annualized loss expectancy, or ALE, which is basically single loss expectancy, meaning once this successful attack occurs only one time, how much you're actually losing in terms of dollar amount, multiplied by how many times this attack actually occurs, a successful one occurs throughout a year. Then that gives you a dollar amount you're going to be losing throughout a year once there is a successful attack happening, the same one, the same kind, throughout a year. So that's what we mean by annualized loss expectancy. Now, the next thing to consider is the cost of deploying these safeguards, or countermeasures, or controls, because you need to consider, remember we talked about this cost-benefit analysis, so how much money are we investing by deploying these safeguards or controls? So the deployment value can be in terms of the cost of purchase, development, and licensing. That's one way to look at it. The cost of implementation and customization, cost of annual operation, maintenance, administration, etc. So here, remember that it's not just the cost of purchasing something in terms of your countermeasure. You have to also consider the cost of maintaining that countermeasure. The next is the cost of annual repairs and upgrades in the same context, productivity improvement or loss. So once you have your control in place, that could have an adverse effect on your productivity, so you have to also consider that cost. And then also changes to the environment, cost of testing and evaluation, the list goes on and on. So now we have, for example, these numeric values such as annualized loss expectancy, and also we calculated the cost of countermeasures. We can actually do this cost-benefit analysis, and here I'm going to introduce a formula you can use to do this cost-benefit analysis. So we now know what annualized loss expectancy is, but there are, or there could be, two different kinds of ALEs, meaning annualized loss expectancy before safeguard was deployed, and also after a safeguard was deployed. So we have to understand the annual loss expectancy before safeguard. So we have to subtract ALE, annualized loss expectancy after safeguard, from ALE before safeguard, which will give us how much benefit we're getting out of the safeguard. But then the safeguard is not free, so the benefit amount, we have to also consider the annual cost of the safeguard. So that's why we have to subtract annual cost of safeguard from also the ALE before safeguard. So that way we're considering the cost of the safeguard. So that's actually giving us this value of the safeguard to an organization. And there are some other things to consider too, other than, for example, the cost of the safeguard. So one is the legal responsibilities. Although, for example, based on the cost-benefit analysis, it turns out that it's not worth trying a particular control. If it's legally required, I mean, there's no question again about it. You have to do it no matter what. Another thing is whether this control is somehow associated with showing that you are practicing this prudent due care regarding your security concerns. You may also have to give it a second thought. And the bottom line here is, although based on this formula, if you have this positive value in terms of your cost-benefit analysis, that's when you want to apply your control. Even if you get a negative value, you may sometimes have to still use that control because it's required by the law or regulations and so on.